Good morning. I think we have to do two sums from exercise 4.1, and then an important part. We will discuss angle between lines represented by ax square plus twice hxy plus by square equal to 0. Let me explain first. This is sum number 8. If the slope of one of the lines given by ax square plus twice hxy plus by square equal to 0 is 4 times the other, show that 16h square equal to 25ab. Now this could have been framed as find the condition, right? Solution, let m1 and m2 be the slopes of the lines given by ax square plus twice hxy plus by square equal to 0. You are allowed to write this directly, or you can obtain auxiliary equation, and from that you get the same m1 plus m2 minus 2h upon b. And what is m1 m2? It is a upon b. Now what is given? We are given that m2 is 4 times m1. So put this in this equation to get phi m1 equal to minus 2h upon b. So what is m1? Minus 2h upon b. Now product is a upon b. So m1 into what is m2? M2 is nothing but 4m1. So we get 4m1 square is a upon b. But m1 is minus 2h upon b. Substitute, simplify to get required answer. So this is the required condition. Now, sum number 9. Let me read the sum for you. If one of the lines given by ax square plus twice hxy plus by square equal to 0 bisects, it should be bisects as one of the lines. So line bisects an angle between the coordinate axes, then show that a plus b square equal to 4h square. Okay, now what is the auxiliary equation? It is bm square plus 2hm plus a equal to 0. Now one of the lines bisects an angle between axes. What will be the inclination? Either 45 degrees or 135 degrees. I'll tell you why. See, this line bisects angle between axes. Its inclination is 45. Now this line also bisects angles between axes. So what is the inclination? 135. So what is slope? It is either tan 45 degrees, which is 1, or tan of 135 degrees, which is minus 1. So m is either 1 or minus 1. Now this is a root of auxiliary equation. So put this in 1. So b into plus minus 1 square, which is just 1. So just b plus 2h into plus minus 1 plus a equal to 0. Now I shift this term to RHS. You can even write plus minus because minus plus is same as plus minus. A plus b is same as b plus a. So square. So square of a plus b. What is square of plus minus 2h? 4h square. So this is the required condition. Now the next important part is angle between lines represented by ax square plus twice hxy plus by square equal to 0. Usually this part is asked for 4 marks in board exam. Just listen to me. You're not supposed to write. The theorem is if theta is the acute angle, between the lines given by ax square plus twice hxy plus by square equal to 0, then tan theta equal to mod of 2 root h square minus ab upon a plus b if a plus b is not equal to 0. Yeah, I agree that we need not write numerator in the modulus, but modulus of positive number is defined. So this complete part is written under modulus. Okay. Actually, there are two methods. I'll explain both the methods. Let m1, m2 be the slopes of the lines represented by which equation? Represented by ax square plus twice hxy plus by square equal to 0. Okay, I write this as number 1. Now, if m1, m2 are the slopes, as lines pass through origin, they must be y equal to m1x and y equal to m2x. That is m1x minus y equal to 0. and m2x minus y equal to 0, right? Now what will be their joint equation? Joint equation will be m1x minus y into m2x minus y equal to 0. Now if you open the bracket and rearrange the terms, you get m1 m2 x square, okay, minus in bracket m1 plus m2 xy plus y square equal to 0. This is equation 2. Now note that 1 and 2 represent the same pair of lines. Why? Because I have started with let m1, m2 be the slopes of the lines given by this equation, right? And this is in fact joint equation. So these are the separate, and again this is joint equation. Now if two equations represent the same thing, then their coefficients are, don't say equal, their coefficients are comparable. Therefore, I'm not writing that as 1 and 2 represent the same two lines. We compare their coefficients. I'm writing directly. So m1, m2, I'm comparing coefficient of x square. In 2 it is m1, m2, and in equation 1 it is a. So m1, m2 upon a equal to minus in bracket m1 plus m2. This is coefficient of xy upon 2h. And what about constant? 1 upon b. Now you may say, sir, we are getting the same. So can we write directly? The answer is no, because this will be asked for 4 marks. So you have to prove this. So what is m1 plus m2? It is minus 2h upon b. Okay. And what is m1, m2? m1, m2 is nothing but a upon b. I hope you are getting this. I compare these two, rearrange the terms to get this. And we already know that m1 plus m2 is minus 2h upon b. And what is m1, m2? A upon b. Now, I hope you remember the formula that if theta is an acute angle between the lines, theta is an acute angle between the lines, acute angle between the lines having slopes m1, m2, then what is tan theta? Mod of m1 minus m2. Do we know m1 minus m2? No, we don't. Upon 1 plus m1 m2. We know m1 m2. Now, unknown is to be expressed in terms of knowns. So can I say, in fact, we have done this at least 2-3 times before. So m1 minus m2 square is m1 plus m2 square minus 4 m1 m2. We have expressed unknown in terms of knowns. So this is 4 h square upon b square minus 4a upon b. Find LCM. It is b square. So what is numerator? 4h square minus 4ab. So that is 4 in bracket h square minus ab upon b square. Is that clear? And therefore, what is mod of m1 minus m2? It is nothing but 2 root h square minus ab upon b. Okay. Now I will mention the formula that if theta is an acute angle between the lines with slopes m1 and m2, what is tan theta? It is mod of m1 minus m2 upon 1 plus m1 m2. Now just substitute the values. So this is 2 root of h square minus ab divided by b upon 1 plus a upon b. Now here I write this as b plus a, that is a plus b upon b. So b gets cancelled and finally we get tan theta equal to mod of 2 root h square minus ab upon a plus b. That's it. Of course, a plus b should not be equal to 0. Is that clear? I'll write this. Provided a plus b is not equal to 0. Let us consider two cases. Lines are perpendicular to each other. So in that case, m1, m2 will be what? Minus 1. That is a upon b equal to minus 1. That is a equal to minus b. That is a plus b equal to 0. But what is a? Coefficient of x square. What is b? Coefficient of y square. What is the criterion? A plus b should be 0. That is coefficient of x square plus coefficient of y square equal to 0. Now second case, lines are parallel. Basically, both lines pass through origin. Suppose this is the first line. Can we draw a distinct line which is parallel to this and which again passes through origin? No. So here, instead of saying parallel, we should say coincident. So that is the special case of parallel. Okay. So M1 equal to M2 for parallel. So M1 minus M2 is 0. So this is 0. This will be 0 if h square minus AB is nothing but 0. So what is the condition for lines to be coincident? That is parallel. H square minus AB should be equal to 0. Exercise 4.2, first sum, show that the lines represented by 3x square minus 4xy minus 3y square equal to 0 are perpendicular to each other. Now, actually in exam, you can say that compare this with ax square plus twice hxy plus by square equal to 0 to get a equal to 3, b equal to minus 3. A plus b is 0. So lines are perpendicular to each other. But here I will use different method. Redden. Auxiliary equation is minus 3m square minus 4m plus 3 equal to 0, where m is slope. Now m1 m2, 3 upon minus 3 equal to minus 1. So lines are perpendicular. As I said, you may write here coefficient of x square plus coefficient of y square is 3 plus minus 3 equal to 0. So lines are perpendicular to each other. Actually, the second question goes like this. Show that the lines represented by x square plus 6xy plus 9y square equal to 0 are coincident. I repeat the question. Show that the lines represented by x square plus 6xy plus 9y square equal to 0 are coincident. Write the solution. Comparing, right? Comparing x square plus 6xy, comparing COMPARING. Don't write come in pair. COMEPAIR, absurd. Comparing x square plus 6xy plus 9y square equal to 0 with ax square plus twice hxy plus by square equal to 0 to get a equal to 1, 2h equal to 6, that is h equal to 3. And what is b? B equal to minus 4. See, if you write values directly, you won't get marks for that. You have to write this, that comparing and so on. Now, h square minus ab equal to 3 square minus 1 minute. I'm sorry. B is 9. I took the value from the next one. B is 9. So 3 square minus 1 into 9 equal to 0. Therefore, lines are coincident. Lines are coincident. Third sum, find the value of k if lines represented by kx square plus 4xy minus 4y square equal to 0 are perpendicular to each other. Now do not write this directly. In exam you have to say comparing given equation with and so on. Actually there is no need to find the value of h because as lines are perpendicular, a plus b equal to 0. We do not need h. So here k minus 4 equal to 0, that is k equal to 4. Fourth sum, find the measure of the acute angle between the lines represented by first equation 3x square minus 4 root 3xy plus 3y square equal to 0. See, in exam you are supposed to write comparing the equation 3x square minus 4 root 3xy plus 3y square equal to 0 with ax square plus 2hxy plus by square equal to 0 to get. Here I have directly written this, but in exam you are supposed to write the first part. To get a equal to 3, 2h as minus 4 root 3. So what is h? Minus 2 root 3. And what is b? 3. Now you have to write acute angle theta between lines is given by. Now many students, they find this part separately. That is also correct. That is also correct. But here I have directly written the values. So 2 into. Now I will directly write h square. Otherwise what happens? Many students write h square as negative only. No. If h is minus 2 root 3, what is h square? It is nothing but 12. So 12 minus AB. So minus 3 into 3. Okay. Upon A plus B. That is 3 plus 3. Simplify this. So this is twice root 3 upon 6, that is 1 upon root 3. Or I will write one more step, root 3 here upon 3 and then 1 upon root 3. Now can you tell me the acute angle whose tangent ratio is 1 by root 3? 30 degrees. Therefore theta equal to 30 degrees. That is how many radian? Pi by 6 radian. Second and third for homework. See that in second, joint equation should be, take it as 4x square plus 5xy plus y square equal to 0. And the answer is tan inverse 3 by 5. See, every time we will not get standard angle. In the third part, what is the answer? Theta is 45 degrees. Now fourth one, compare a square minus 3b square x square plus 8abxy plus b square minus 3a square y square equal to 0 with, observe that small ab are already used. So we should say compare with capital A x square plus 2 capital H xy plus capital B y square equal to 0 to get capital A as what? Coefficient of x square, a square minus 3b square, twice h, 8ab. So what is h? 4ab. And what is capital B? B square minus 3a square. Now here I'm going to obtain h square minus ab and a plus b separately. And then I'll put the values in the formula. So substitute the values. H square minus AB becomes 16a square b square minus product of these two. I have omitted one step. You could have opened these brackets and then multiply by minus 1. So on simplification, h square minus AB comes out to be 3 into square of a square plus b square. So what is root h square minus AB? It is root 3 into a square plus b square. This cannot be negative. So there is no need to write this under modulus. Now what is a plus b? A plus b comes out to be minus 2 into a square plus b square. Then I will write, therefore acute angle theta between lines is given by, here you have to read between the lines in the topic pair of lines. Tan theta is mod of 2 root of, remember we have used capital letters, h square minus ab upon a plus b So 2 root 3 a square plus b square upon minus 2 so what is the required angle? 60 degrees. Now this is an important sum. Fifth one. Find the combined equation of lines passing through the origin, each of which making an angle of 30 degrees with the line 3x plus 2y minus 11 equal to 0. Solution. Now what is the slope of 3x plus 2y minus 11 equal to 0? It is minus 3 by 2. Let m be the slope of one of the lines making 30 degrees with the line 3x plus 2y minus 11 equal to 0. Now angle between lines with slopes m and m1 is 30 degrees. Now what is the formula? Tan theta is mod of m minus m1 upon 1 plus mm1. What is theta here? 30 degrees. And what is tan 30 degrees? 1 by root 3. So we get 1 upon root 3 equal to mod of m minus minus 3 by 2, slope of the given line, upon 1 plus m into minus 3 by 2. Rearrange the terms to get this. Now square both the sides, cross multiply, rearrange the terms to get this equation. Usually we are given the joint equation and we obtain auxiliary equation. Here we have got an auxiliary equation and from this we have to obtain joint equation. This is auxiliary equation of the two lines and their joint equation is obtained by putting m equal to y by x. Why? If somebody asks you, you should be able to give the answer. Line through origin is always y equal to mx, where m is the slope. So m is nothing but y by x. So replace m by y by x. Again simplify to get final answer as 23x square plus 48xy plus 3y square equal to 0. Sum number 6. If the angle between the lines represented by ax square plus twice hxy plus by square equal to 0 is equal to angle between the lines 2x square minus 5xy plus 3y square equal to 0, then show that 100h square minus ab is square of a plus b. So you have to be very careful. I remember in one exam it was given ax square plus hxy and not twice hxy. Luckily here twice hxy is given. So write the solution. I'll dictate initial part. Right now, the acute angle theta between the lines, ax square plus twice hxy plus by square equal to 0 is given by, right, is given by tan theta equal to, now you should be able to write this on your own. Tan theta is mod of 2 root h square minus ab upon a plus b, number 1. Comparing, next line, comparing 2x square minus 5xy, comparing 2x square minus 5xy plus 3y square equal to 0 to get, comparing 2x square minus 5xy plus 3y square equal to 0 with ax square plus 2hxy, with ax square plus 2hxy plus by square equal to 0 to get a equal to 2, small a equal to 2, h equal to, I'm directly telling the value of h equal to minus 5 upon 2, h equal to minus 5 by 2, and b equal to 3. Now initially I will say, therefore angle between lines is tan alpha. You can use any other, and then I'm going to say that they are equal. So tan theta equal to tan alpha. Therefore tan alpha equal to, substitute the values, 2 root of h square minus ab. You could have directly written 25 by 4 minus 2 into 3 upon 2 plus 3. Simplify this. So this is 2. I'm writing this directly. 25 by 4 minus 6 is 1 by 4. So I'm directly writing 1 by 4. So this is 2 into half upon 5. That is 1 upon 5. This is second equation. Right down. But I have to say tan theta equal to tan alpha, because we are given that angles are same, so the tangent ratios will be the same. So twice root h square minus ab upon a plus b is 1 by 5. On squaring both sides, so we get 4h square minus ab upon square of a plus b is 1 by 25. Cross multiply to get 100 h square minus ab equal to square of a plus b. So this is the required condition. Seventh, this is again an important sum. Find the combined equation of lines passing through the origin and each of which making an angle of 60 degrees with the y-axis. See, you have to consider this as, see, this line OA makes 60 degrees with y-axis. So this angle is 60 and OB makes 60 degrees. So this angle is 60 degrees. Okay. Let OA and OB be the lines through origin making 60 degrees with y-axis. So what will be the inclinations of these lines? For OA, this is 60. So what is the inclination? 30 degrees. So what is slope of this line OA? Tan 30 degrees, that is 1 by root 3. What about inclination of OB? See, this is 90 plus 60, so 150 degrees. So what is the inclination? 150 degrees. So what is the slope of OB? Tan 150 degrees, which is tan of 180 minus 30, that is minus tan 30, that is minus 1 by root 3. Before that, they have written equation of line OA is y equal to mx, slope m is 1 by root 3. So x minus root 3 y equal to 0. And that of line OB is y equal to minus 1 upon root 3x, that is x plus root 3 y equal to 0. So what is the joint equation? X minus root 3y into x plus root 3y equal to 0. That is x square minus 3y square equal to 0. So this is the joint equation. See, in the first part, we discussed lines through origin. Now, in the second part, we will be considering any two lines. So before I explain that, let me explain general second degree equation in x and y. See, the equation of the form ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0. Which equation? Ax square plus twice hxy plus by square plus 2gx plus 2fy plus c equal to 0, where at least one of a, b, h is non-zero, is called a general second degree equation in x and y. Okay. Now, why to discuss this? Because we are going to discuss one theorem. The statement is the combined equation of two lines, any two lines, is a general equation of second degree in x and y. See, in the first part, we discussed lines through origin. So the theorem was combined equation is a second degree homogeneous equation. Now we are considering any two lines. So the combined equation is general second degree equation in x and y. Now proof is simple. If the equations of the two lines, any two lines, so a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, right? Then what will be their joint equation? Joint equation will be a1x plus b1y plus c1 into a2x plus b2y plus c2 equal to 0. Now, if you open all the brackets, you get a term in x square, you get a term in xy, you get a term in y square, then a term in x, term in y, and a constant term. And that is why we take that as ax square plus twice hxy plus by square plus 2gx plus 2fy plus c equal to 0. Again, you may ask me why 2h, why 2g, why 2f, and then why not 2b, 2c, 2a, etc. The logic is simple because from this we have to obtain number of things. As in the first case, we obtain angle between lines. That expression is simple or will be in simple form if we consider twice h instead of h. Again, this equation need not represent pair of lines in all the cases. So there is one criterion. That criterion can be obtained in simple form if we take 2g, 2f instead of g and f. Is that clear? So this is the reason. So the conclusion is the general, rather the joint equation of pair of lines is a general second degree equation in x and y, which is usually taken as this one. But every general second degree equation in x and y will not represent pair of lines. Same logic. X square plus y square equal to 0 or x square plus y square equal to minus 11. This is general second degree equation in x and y. Does this represent pair of lines? No, it doesn't. Is that clear? So what is the criterion? What is the criterion? In fact, criteria, there are two. What are the criteria for this equation to represent pair of lines? Now, the next part is important. As I said, what are the criteria for that equation to represent pair of lines? Okay. Now, listen to me carefully. The condition that the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 should represent a pair of lines are, rather conditions are, first condition, determinant AHG, second row, HBF, third row, GFC. What is the speciality of this determinant? If you interchange all the rows and columns, you get the same elements in that order. Or if I say that if this is a matrix, then this is symmetric matrix because transpose is the same as original one. But remember, this is not a matrix, this is a determinant. Okay. So AHG is first row, first column, and so on. So if this value of the determinant is 0 and h square minus AB is greater than or equal to 0, then and then this equation will represent pair of lines. Now you are expected to remember the expansion also. You know how to expand a determinant of order 3. So that expansion is ABC plus twice FGH minus AF square minus BG square minus CH square. So this has to be 0. In many cases, it is better that we go for this expansion, okay, instead of writing elements in determinant. Anyway, we have to expand that. So these two, if these two criteria are satisfied, if these two conditions are satisfied, then this equation definitely represents pair of lines. Now, I think from this, you can conclude that as h square minus AB is greater than or equal to 0, the same formula is to be used to find the acute angle between the lines given by general equation. Yes, same formula. Let me explain that. First, I will write the formula. Now, next part of discussion is angle between the lines represented by same equation, ax square plus twice hxy plus by square plus 2gx plus 2fy plus c equal to 0. See, the lines given by, listen to me carefully, lines given by this equation are parallel to lines given by which equation? Ax square plus 2hxy plus by square equal to 0, right? So formula for finding angle between lines given by this equation is the same as for formula for finding angle between lines given by ax square plus 2hxy plus by square equal to 0. So in this case also formula remains the same. Tan theta is mod of 2 root h square minus ab upon a plus b, provided, this is important, a plus b is not equal to 0. So in that case also criterion for perpendicular lines is the same. Coefficient of x square plus coefficient of y square should be 0. That is a plus b equal to 0. And lines will be, now I will say parallel, because general equation need not represent lines through origin. So I will say parallel. So lines will be parallel if h square minus ab is nothing but 0. Is that clear? See, if these are the lines represented by general equation, then lines parallel to these two passing through origin will be represented by which equation? Second degree homogeneous equation. So angle between these two lines is the same as angle between these two lines. And that is why we use the same formula. Tan theta is mod of 2 root h square minus ab upon a plus b. Now, point of intersection. See, if the general equation of second degree in x and y, that is ax square plus twice hxy plus by square plus 2gx plus 2fy plus equal to 0 represents a pair of intersecting lines, then their point of intersection, say px1y1, is obtained by solving any two of the following equations. Now you will ask me, sir, how to remember this? Yes, can be remembered easily. We have already seen this determinant. AHG, HBF, GFC. Observe three equations. See, AHG, AHG. Second equation has coefficients HBF, HBF. Third equation, GFC. Okay. Solve any two equations. So by Kramer's rule, we get point of intersection as what? X coordinate is BG minus HF upon H square minus AB. Y coordinate is AF minus HG upon H square minus AB. This is logical because if lines are parallel, they do not intersect. In that case, we should not get point of intersection. And in fact, we do not, because if lines are parallel, H square minus AB, that is denominator, vanishes. Is that clear? Now, the last part, see, you can use this in CET only. In board exam, if you are asked to find point of intersection, then you have to write any two of these three equations, solve them and get the point of intersection. One more method is, some students will say, sir, we will operate, rather we will obtain separate equations and then we will solve them. Yes, that is also correct. Now the last part, that is combined equation of bisector of angle between the lines ax square plus twice hxy plus by square equal to 0. See, I am considering which equation? Ax square plus twice hxy plus by square equal to 0. So what is that? It is hx square minus in bracket a minus b xy minus hy square equal to 0. What does this equation represent? Basically, this is combined equation of bisector of angle between the lines given by this second degree homogeneous equation. Is that clear? So that's it for today.